Okay, I'm a bit slow here, but we left it at the end of the medieval warm period around 1200 Common Era. So let's take a step forward in time to the Little Ice Age, which we have mentioned before. We will look more specifically at some of the epidemics. In fact, we already mentioned the Black Death as well. We will revisit some details, and even though lots of the literature has focused on Little Ice Age and its impacts over Europe, it did have its footprint on China, Pacific Islands, New Zealand, and so on. So we'll briefly mention those things as well. So here is a nice figure that's showing again time going forward here from 900 CE to 2000 with major volcanic eruptions put in there. Why? Because whenever you want to cool the climate, you can majorly do it with a few ways. One is orbital forcing, where you change the orbital configurations of ellipticity, precession, and obliquity to create radiative perturbations, which will begin to build glaciers and ice age, for example, or you have volcanic eruptions which can increase so much that they begin to cool the climate. So volcanoes put in a lot of aerosols, especially in the stratosphere, which can block sunlight and have massive impact on temperatures for a few years. But if you have a series of them, you can trigger cold periods as well. And the third way is to do it through solar activity, which are shown here as Wood minimum, medieval maximum, Wolf minimum, Sporer minimum, Maunder minimum, and modern maximum. Essentially, if you don't already know, what happens here is that the sunspots that are magnetic knots on the sun actually create a brighter spot around them. So when you have more sunspots, the radiation output from the sun increases, so you get more radiation on the sun. So you can see that whenever you have these minima in sunspot, if you look at the solar relative solar activity here, you get less radiation. So on during sunspot maxima, you get more radiation. So during the Little Ice Age, you have this series of minima in solar activity, Wolf, Sporer, Maunder being the most famous one, and the modern maximum, which happened up to about 2000, was being used by some people to say global warming during the 20th century was caused by solar radiation, but actually that doesn't work at all, especially if this is considered as the start of the warming since the Industrial Revolution, and you would think maybe there is a correlation. Actually, the radiation forcing associated with it does not explain the warming we have observed because of fossil fuel greenhouse gas increases. Okay. So here is the temperature anomaly. You have medieval warmth that was still going on into about the 11th century. Then it started dipping, natural variability, and then there were volcanic activities as well as the beginning of these solar minima, and we stayed in this relatively cold period. So variations in European temperature relative to 20th century average and in solar activity during 900 to 2000 CE. Several major historical events are shown, as are the two phases of the cooling temperature graph adapted from this report here. So the major events: medieval warming, the Norse Vikings settled Iceland and Greenland and made it all the way to North America as far as we know. The Great Drought, Northern and Central America over these periods as the cooling started. Cooling of the earth in general always brings drought in many places because the rainfall requires evaporation, loading of the moisture into the atmosphere, and that's what produces rainfall. The Great Famine of Europe, right here, that's the major event. Black Death, which we will touch on again, we already mentioned it. That's pretty massive. there were recurring plagues happening over the next couple of centuries, which probably resulted in deaths up to 200 million. So it started somewhere in Europe or in China, came to Europe, probably went back and made several cycles, and ended up with the Great Plague recurrence for essentially almost 2 centuries. And you have the Tambora eruption that happened in 1816, and there was another one at 1896, which was Krakatau, I think, and then another big one that probably here. I don't remember which year it is. Okay, so these are 2 phases of the Little Ice Age here, and then a little bit of recovery, and then again cooling. The end of the Little Ice Age may have come because of the coal burning and the release of carbon particles onto the glaciers in the Alps and so on, which would absorb more solar radiation and hasten the melting of the glaciers. Nonetheless, the end of the 18th century into the 19th century was quite a perturbed climate, relentlessly changing climate because of volcanic eruption, because of a big El Nino that lasted or repeated for several years, and we will see some of those as well. So all of these had disease problems, pestilence, typhus, all the waterborne diseases we talked about, plagues, diarrhea, flu, potentially flu mixed in, because some of the causes of deaths, or even whether this was really plague or something else, is not completely settled. Of course, there were malaria and so on as well in other parts of the world. Okay. Annual variations in the grain price and estimated rates of marriage and death in southern England during the Great European Famine of 1315 to 1322. Note the unusual occurrence of 2 consecutive back-to-back harvest failures in 1315, 16, and 17. Single-year harvest failure and price rises, as in 1321, had little effect on marriages and deaths. People coped. One perturbation doesn't do necessarily serious damage, but when it repeats, then people begin to become more and more vulnerable, and things begin to fall apart. So annual number of marriages times 4 and deaths times 0.5 to fit them onto the scale. So the indexed grain price is shown here as well. So grain prices collapsed and then jumped, and you can see these peaks and drops in grain prices, marriages that also went along with this, and deaths increased. And this is all directly driven by climate. Again, North Atlantic Oscillation was part of the story, where it switched the westerlies to bring warmer, more rain to the northern parts, over to Norway, Sweden, Scandinavian countries, and destroyed the crops, agricultural production, and created grain price problems over the UK, and then obviously tends to also correlate with diseases, malnutrition, interactions with mice, plague, and so on. Okay, the spread of the Black Death in Europe during 1346 to 1353. So you can see there are multiple regions with different years of plague, including Western Russia going in here and into the Middle East, and North Africa down here, Alexandria, Egypt, Damascus, Syria down there, but Tunis and so on here. In the year preceding the major Black Death plague outbreak, urban centers were contaminated by ships returning to port at the end of the sailing season. So these were regions that were connecting to the Asian trades in silk and spices and other things, gold, timber, etc. Okay, a small outbreak occurred but was suppressed by cold autumnal and wintry weather. It lay dormant in the rat colonies until re-emerging in the spring with warmer weather. So some interpretations insist that it was the the unusual seasonality of the outbreak was related to these kind of climate changes as well, or at least seasonality of the anomalies. But there is persistent doubt about whether this was really bubonic plague or it was something else like a flu. Okay, you remember the Spanish flu that came later on, also killed 50 million people in the 20th century, 1918 or so. Okay, so you can see the propagation or infection spreading all the way to Moscow, down here in Kaffa, Constantinople, back towards the Middle East, Messina, North Africa, into Europe, Geneva, Barcelona, and up into the UK and even into the Scandinavian countries here. Okay, so these are the different years being shown here. So the other outbreak, maybe I'll come to in the next podcast and also talk about other regions where we had impacts of the Little Ice Age, the freezing, not necessarily related to health, but China, we will look at some epidemics that were related to climate anomalies with some general conclusions. Many of the other events here, including the French Revolution and so on, have been potentially related to the epidemics and health issues, impacts on the military, conflicts, malnutrition, mortality rates, and so on and so forth. So the climatic perturbations can drive conflicts, and conflicts can spread the infections and contagious diseases, and can get into this loop where you have a background cooling happening. So the background cooling may itself have started food shortages, and then military adventures may have been driven by that, and then confounding the health issues like the spread of the plague around like this. Okay, so those are not always easy to disentangle unless you have very detailed data, but the message we must carry always is that epidemics typically have always been related to perturbations in climate. Okay, including COVID, all said and done, will turn out that global warming combined with people's movements probably created ideal conditions for a pandemic during this time in the 21st century.